Welcome back to my Chem Corner. In today's video, we are doing another question from chemical bonding and molecular structure, which is question number 4.8. Now, in this question, it says, although the geometries of ammonia and H2O molecules are distorted tetrahedral, bond angle in water is less than that of ammonia. Discuss. So here, when we say distorted tetrahedral, first you need to understand one thing, that when you look at the molecules given to you, one is ammonia and the other one is water. Okay. When I try to draw the structure of this, I have 3 hydrogens, 2 nitrogen, and nitrogen belongs to group 15, so it will have one lone pair of electrons. When I look at water structure, all right, I have 2 hydrogens, and then oxygen belongs to group 16, therefore I have 2 lone pairs of electrons. Now, so when you look at ammonia, it has 3 bond pairs. This is one bond pair, this is another one, and this is the third one. So it has 3 bond pairs. In water, you have 1 and 2. So here you have 2 bond pairs. Whereas if you look at ammonia, it has only 1 lone pair. In water, there are 2 lone pairs. So you see the number in the bond pairs and the lone pairs are different here. Okay. Now, one of the postulates of the VSAPR theory clearly says that when you have lone pairs and bond pair, the lone pair repulsion is greater than lone pair bond pair repulsion, which is even greater than bond pair bond pair. So the greatest repulsion is observed in those molecules that have 2 lone pairs in which the repulsion is greater, and the least is observed in those molecules which have only bond pair. Okay, so in the previous videos we saw that when you have just bond pairs and no lone pairs, there is no deviation in the geometry, right? If you have 4 bonds around the central atom, it has to be a tetrahedral. If you have 3 bonds around the central atom, it is going to be trigonal planar. So there was no deviation at all in the previous video that we had done. But we have also seen the same video that the minute you have lone pairs, there will be deviation. Now both of this, ammonia as well as water, the expected geometry is tetrahedral. But due to this repulsion, there is a change in the geometry. So for ammonia, the geometry is trigonal pyramidal, and for water it is bent. So they are basically changing from a tetrahedral to these geometries. So tetrahedral, if they were, what would be the bond angle? The bond angle is 109.5 for both. But what happens here is, in ammonia, there is a repulsion between lone pair and bond pair. So this lone pair has a repulsion between the bond pairs. So when they are in the tetrahedral, so this is the tetrahedral structure of ammonia, and this is 109. What happens here is, there will be a repulsion between these lone pair bond pair, therefore pushing the bond downward to give you a trigonal pyramidal. So what happens when it is moving to trigonal pyramidal, the bond angle will shift to 107 degrees in case of ammonia. That is when you will get trigonal pyramidal geometry. In case of water, the same thing. You try to draw the structure for a tetrahedral shape. This is what you get. This is going to be the tetrahedral shape, and here you have 109 degrees. Okay, 109.5. This is the tetrahedral. But what happens here is, in this case, there are 2 lone pairs. Maximum repulsion is seen here, pushing them away. So when they push them away, what happens? Now you have a bond angle of 104.5. So now it changes to 104.5. Okay, so here when you see, this is changed to 107 and this is changed to 104.5. So this clearly tells that in case of water, you have lone pair repulsion. Therefore, the bond angle in water is less, because in water it is 104.5, whereas the bond angle in ammonia is 107. This is due to lone pair repulsion in water, and in ammonia it is due to lone pair bond pair repulsion. Okay, because the question is asked comparing both, you need to compare for both and then give the reason for it.